Bathrooms are generally defined as rooms containing toilets, sinks, and/or showers or bathtubs. A basin area, due to its containing a sink, is considered an integral part of the bathroom, irrespective of whether it is in a separate room or not. This distinction is important because electrical codes often mandate that sub-panels be located outside bathroom areas due to potential moisture and electrical hazards. Relocating sub-panels away from the basin ensures adherence to electrical safety regulations. Electrical safety is paramount in any building, particularly in areas prone to moisture like bathrooms. The presence of water significantly increases the risk of electric shock, making it crucial to follow established electrical codes. The National Electrical Code, or NEC, provides comprehensive guidelines for safe electrical installations. These guidelines aim to minimize the risk of electrical hazards. The NEC specifically addresses the placement of electrical panels, including sub-panels, in relation to areas like bathrooms. The primary reason for restricting panel placement in bathrooms is the increased risk of electrical shock. Water is an excellent conductor of electricity, and bathrooms are inherently wet environments. A sub-panel located in a bathroom is more likely to come into contact with moisture, potentially creating a path for electricity to flow through water to a person. This can result in severe injury or even death. Furthermore, the presence of moisture can corrode electrical components within the sub-panel, leading to malfunctions and potential fire hazards. The NEC defines bathrooms broadly to include any area containing a sink, toilet, shower, or bathtub. This definition ensures that all areas with potential water exposure are subject to the same safety regulations. Even if a sink is located in a separate room adjacent to the toilet and shower area, it is still considered part of the bathroom for electrical code purposes. Therefore, a basin area containing a sink falls under this definition and is subject to the same restrictions on electrical panel placement. When installing or relocating a sub-panel, it is essential to carefully consider the location in relation to bathroom areas. The sub-panel should be placed outside the defined bathroom space to comply with the NEC guidelines. This may involve relocating the panel to an adjacent room, hallway, or closet that is not considered part of the bathroom. It is crucial to consult with a qualified electrician to determine the appropriate location for the sub-panel and ensure compliance with all applicable electrical codes. A qualified electrician has the knowledge and experience to assess the specific layout of the building and identify any potential hazards. They can also advise on the best way to relocate the sub-panel while maintaining electrical safety and functionality. In addition to relocating the sub-panel, it is also important to ensure that the existing electrical wiring is properly grounded and protected. Grounding provides a safe path for electricity to flow in the event of a fault, minimizing the risk of electric shock. Ground fault circuit interrupters, or GFCIs, are also essential in bathrooms to protect against electrical shock. GFCIs are designed to detect even small changes in electrical current and quickly shut off the power, preventing a potentially fatal shock. The NEC requires GFCIs to be installed in all bathroom receptacles as well as other areas where water is present. When relocating a sub-panel, it is crucial to follow all NEC guidelines and local electrical codes. This includes obtaining the necessary permits and inspections to ensure that the work is done safely and correctly. Failure to comply with electrical codes can result in fines, penalties, and potential safety hazards. Therefore, it is always best to hire a qualified electrician to perform any electrical work, particularly when it involves relocating electrical panels. In summary, a basin area containing a sink is generally considered part of the bathroom for electrical code purposes. Sub-panels should be located outside of bathroom areas to minimize the risk of electrical shock and comply with the NEC guidelines. Relocating a sub-panel requires careful planning and execution, and it is essential to consult with a qualified electrician to ensure that the work is done safely and correctly. By following these guidelines can significantly reduce the risk of electrical hazards and create a safer environment. Now, let's elaborate further on the technical aspects of sub-panels, electrical codes, and safety measures. A sub-panel, also known as a load center or panel board, is a distribution point for electrical power within a building. It receives power from the main electrical panel and distributes it to various branch circuits throughout the building. Sub-panels are typically used in larger buildings or homes with multiple circuits to provide more localized control and protection. The NEC provides detailed requirements for the installation and wiring of sub-panels. These requirements cover various aspects, including the size of the conductors, the type of overcurrent protection, and the grounding and bonding of the panel. The size of the conductors used in a sub-panel is determined by the amount of current they are expected to carry. The NEC provides tables that specify the allowable ampacity of different types of conductors based on their size and insulation. It is essential to use conductors that are large enough to handle the expected current load to prevent overheating and potential fire hazards. Overcurrent protection is provided by circuit breakers or fuses, which are designed to interrupt the flow of current in the event of an overload or short circuit. The size of the circuit breakers or fuses must be matched to the ampacity of the conductors they are protecting. The NEC provides guidelines for selecting the appropriate overcurrent protection for different types of circuits. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection to trip and to energize the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, preventing voltage differences that could create a shock hazard. The NEC requires that sub-panels be grounded to a grounding electrode system, which typically consists of a ground rod or a connection to the building's metal water pipe. In addition to the general requirements for sub-panels, the NEC also has specific requirements for sub-panels installed in bathrooms. As mentioned earlier, sub-panels are generally not allowed to be installed within the defined bathroom area. This is due to the increased risk of electrical shock in wet environments. However, there are some exceptions to this rule. For example, a sub-panel may be installed in a bathroom if it is specifically designed and rated for wet locations. These sub-panels are typically enclosed in a waterproof enclosure and have special features to prevent moisture from entering the panel. Another exception is for sub-panels that serve only circuits within the bathroom. In this case, the sub-panel may be installed in the bathroom if it is located as far away as possible from the sink, toilet, shower, or bathtub. However, even in these cases, it is essential to consult with a qualified electrician to ensure compliance with all applicable electrical codes. When relocating a sub-panel, there are several factors to consider. Firstly, the new location must be accessible for maintenance and repairs. The sub-panel should be located in an area where it can be easily reached and worked on. Secondly, the new location must be dry and protected from the elements. The sub-panel should not be located in an area where it is exposed to rain, snow, or other sources of moisture. Thirdly, the new location must be large enough to accommodate the sub-panel and any associated wiring. The sub-panel should not be crammed into a small space where it is difficult to work on. Fourthly, the new location must comply with all applicable electrical codes. The sub-panel should be located in an area that meets the NEC requirements for clearance, access, and environmental protection. When relocating a sub-panel, it is also important to consider the impact on the existing electrical system. The relocation may require extending or rerouting existing circuits. It is essential to ensure that any new wiring is properly sized and installed in accordance with the NEC requirements. The relocation may also require upgrading the existing electrical service to accommodate the increased load. If the existing service is not large enough to handle the additional load, it may be necessary to install a larger service panel or upgrade the utility service. In addition to the NEC requirements, there may also be local electrical codes that apply to the relocation of a sub-panel. It is essential to check with the local building department to determine if there are any specific requirements that must be met. The local building department may also require a permit for the relocation of the sub-panel. It is important to obtain any necessary permits before starting the work to avoid potential fines or penalties. When hiring an electrician to relocate a sub-panel, it is important to choose a qualified and experienced professional. The electrician should be licensed and insured and have a proven track record of performing similar work. The electrician should also be familiar with the NEC requirements and local electrical codes. It is a good idea to get multiple bids from different electricians before making a decision. Be sure to compare the bids carefully and ask the electricians about their experience, qualifications, and insurance coverage. It is also a good idea to check references from previous customers. Once you have chosen an electrician, be sure to get a written contract that outlines the scope of the work, the cost, and the timeline for completion. The contract should also include a provision for resolving any disputes that may arise. During the relocation process, it is important to communicate with the electrician and ask any questions you may have. The electrician should be able to explain the work that is being done and answer any concerns you may have. It is also important to inspect the work after it is completed to ensure that it meets your expectations and complies with all applicable electrical codes. In addition to relocating the sub-panel, there are several other safety measures that can be taken to reduce the risk of electrical hazards in bathrooms. Firstly, ground fault circuit interrupters, or GFCIs, should be installed in all bathroom receptacles. GFCIs are designed to detect even small changes in electrical current and quickly shut off the power, preventing a potentially fatal shock. The NEC requires GFCIs to be installed in all bathroom receptacles, as well as other areas where water is present. Secondly, all electrical fixtures and appliances used in bathrooms should be listed by a recognized testing laboratory, such as Underwriters Laboratories or all. This listing ensures that the products have been tested and meet safety standards. Thirdly, electrical fixtures and appliances should be installed in accordance with the manufacturer's instructions. This will help to ensure that they are installed correctly and safely. Fourthly, electrical cords should be kept away from water sources. Cords should not be allowed to dangle into sinks, bathtubs, or showers. Fifthly, electrical appliances should not be used while wet. This includes hair dryers, curling irons, and electric shavers. Sixthly, electrical outlets should be covered with child-resistant covers when not in use. This will help to prevent children from sticking objects into the outlets. Seventhly, electrical panels should be kept clean and dry. Dust and moisture can accumulate in the panels and create a fire hazard. Eighthly, electrical panels should be inspected regularly by a qualified electrician. The electrician can identify any potential problems and make any necessary repairs. Ninthly, carbon monoxide detectors should be installed in all homes. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors can alert occupants to the presence of carbon monoxide, allowing them to evacuate the building and seek medical attention. Tenthly, smoke detectors should be installed in all homes. Smoke detectors can alert occupants to the presence of smoke, allowing them to evacuate the building and call for help. In conclusion, electrical safety is paramount in any building, particularly in areas prone to moisture like bathrooms. Relocating sub-panels away from bathroom areas, installing GFCIs, and following other safety measures can significantly reduce the risk of electrical hazards. It is essential to consult with a qualified electrician to ensure that all electrical work is done safely and correctly. By following these guidelines, you can create a safer environment. To further emphasize, understanding electrical codes is essential for ensuring safety and compliance in electrical installations. These codes, such as the National Electrical Code, or NEC, provide guidelines for the safe installation of electrical systems and equipment. They cover various aspects from wiring methods to grounding requirements. Compliance with these codes is crucial to prevent electrical hazards, protect property, and save lives. Firstly, the National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It is developed by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC provides comprehensive guidelines for electrical wiring, overcurrent protection, grounding, and other aspects of electrical systems. Secondly, local electrical codes are often based on the NEC but may include additional requirements or modifications to address specific local conditions. It is essential to check with the local building department to determine the applicable electrical codes in a particular area. Thirdly, electrical codes are constantly evolving to keep pace with technological advancements and emerging safety concerns. It is important to stay up to date on the latest code changes to ensure that electrical installations are safe and compliant. Fourthly, electrical inspections are conducted by qualified inspectors to verify that electrical installations comply with applicable electrical codes. Inspections are typically required for new construction, renovations, and alterations to electrical systems. Fifthly, electrical permits are often required before starting any electrical work. Permits provide a mechanism for tracking electrical installations and ensuring that they are inspected by qualified inspectors. Sixthly, electrical contractors are responsible for ensuring that electrical installations comply with applicable electrical codes. Contractors should be licensed and insured and have a thorough understanding of electrical codes and safety practices. Seventhly, homeowners are responsible for maintaining their electrical systems in good working order. Homeowners should regularly inspect their electrical systems for any signs of damage or deterioration and should promptly repair any problems. Eighthly, electrical safety training is essential for anyone who works with electrical systems. Training programs cover topics such as electrical hazards, safe work practices, and electrical code requirements. Ninthly, electrical safety equipment is designed to protect workers from electrical hazards. This equipment includes items such as insulated gloves, safety glasses, and arc flash suits. Tenthly, electrical safety awareness is crucial for preventing electrical accidents. Everyone should be aware of the potential hazards of electricity and should take precautions to avoid electrical shocks, burns, and other injuries. Understanding and complying with electrical codes is essential for ensuring electrical safety. By following these guidelines, we can minimize the risk of electrical hazards and protect property.